Hey y'all, in this lesson we are looking at understanding irrational numbers. We want to be able to identify what an irrational number is. So the first thing we're going to do is define an irrational number. An irrational number is a number that cannot be written in the form of a over b, where a and b are integers and b is not equal to 0. So we're going to fill in our notes. This is basically to say that an irrational number can't be written as a fraction. So let's take a look at example 1, identifying irrational numbers. Here, the Venn diagram is showing the relationships among different rational numbers. How would you classify the number 0.24758326 ... Well, to start off, the decimal expansion does not terminate or repeat. So it can't be written as a ratio of two integers because we know that if it terminates or repeats, we know how to change a decimal to a fraction. But if it doesn't, we can't do that. So it does not terminate and it does not repeat. So it is not a rational number. We want to keep in mind that non-repeating, non-terminating decimals will always be irrational numbers. So this number is not a rational number, and we want to keep in mind that non-repeating and non-terminating decimals are always irrational. Try it. Here is a list of numbers for you to classify as either rational or irrational. In example 2, we're going to look at classifying numbers as rational or irrational, and the reason behind our classification. So the first one, negative 81,572. This number is rational. We can rewrite it as a fraction because we can rewrite any whole number as a fraction over 1. Because it can be rewritten as a fraction, it's rational. The square root of 11. Because 11 is not a perfect square, that is where you saw with our estimations that we can't get an exact amount. So the square root of 11. So anytime we don't have a perfect square, that square root is irrational. 5.6363336333 repeats. This is not rational, this is irrational, and even though it kind of has a pattern, it's not repeating, it's not terminating, so it is irrational. And finally, the square root of 16. The square root of 16 is a rational number because we can calculate that. The square root of 16 is exactly 4, and 4 is a number that could be rewritten as a fraction, and so this is rational. So 16 is a perfect square, is why this ends up being rational. You try classifying these numbers. Are they rational or irrational? We will finish with our summary, a very short summary. Numbers that are not rational are called irrational numbers. And again, I have our little sorting numbers, so that can give you a little bit of extra summary. Again, the number 2 is not a perfect square, so the square root of 2 is irrational. And the number 4 is a perfect square, so the square root of 4 is 2, which makes it a natural number, which makes it a rational number. So this is, you can see the different classifications of numbers. Naturals are inside whole numbers, which are inside integers, which are inside rational numbers. irrational numbers are not with that group, but they are all grouped together under the real number system. That is how they're related. Your next steps are to submit your 7.4 notes, work on your Build 7.4, and take your 7.4 mastery check. Good luck.